Hello everyone. Today I would like to share with you how to solve the inverse Laplace transform using the first shift property. Okay, let me show you an example. Inverse Laplace transform of 3s plus 5 divided by s squared minus 4s. Okay, how are we going to solve this question? Okay, if you look at here, we can separate into two because we have the plus here, and we take out the constant, so the constant here is a 3, so 3 inverse Laplace, and then here we have s, and then s squared minus 4s, and another one is plus 5 again is a constant, so we can take it out, and we left 1 over s squared minus 4s. Okay, so this is s squared and 4s, so we can factorize it. So we have s over s minus 4, and then 5, and then here. Okay, how do we obtain s squared minus 4s? How do we obtain? If we want to factorize it, okay, s squared minus 4s, how do we obtain? Okay, one of the method is s minus 2, right? S minus 2 square. Okay, if you s minus 2 square, what do you obtain? S squared minus 4s plus 4. Actually, we can obtain the s squared minus 4s, but we have extra plus 4, which is we don't need, so we minus 4. Okay, so this means that we can change to s minus 2 square minus 4, which is actually the same like what we want here is s squared minus 4s. And then s minus 4 is a shifting property, so we can change to exponent 40 from the table of Laplace transform. This one we can cancel out. Okay, so we have 3, and then this s minus 4 from the table of Laplace transform, we change to exponent 40. If you not remember, we can write it in this way: exponent 80 equal to 1 over s minus a. This is from the table of Laplace transform. And then we left 1 over s. Then plus with 5 inverse. Again, this one we can change to the exponent 2t, and then what we left here is 1 over s squared minus 2 squared. Okay, now we can solve it. 3 exponent 4t, this one inverse Laplace transform of 1 over s, you obtain 1 because the a is you obtain a over s, so you obtain 1 plus 5 exponent 2t inverse Laplace. This one, what we can obtain? We can obtain this one we can obtain the sign, minus, so it's a sinh, so sinh at equivalent to a over s squared minus a squared. So if you refer to the format here and what you have here, okay, so a is 2, so s squared minus 2 squared. But what you have in the question is only 1, so you need to divide by 2. Alright, so your final answer is 3 exponent 4t plus 5 over 2 exponent 2t sinh 2t. Okay. Let me show you another example. Inverse Laplace transform of the 2s minus 3, 2s squared minus 8s plus 16. Okay, we can factorize the 2 here since we have 2s and 8s and 16. So we can factorize. Okay, we can factorize out the 2 and we name it as equation 1. Okay, now how to find out s squared minus 4s? How to obtain? For example, let's say we have a s minus 2, okay, square. What we can obtain here? If you have s minus 2 square, we can obtain s squared minus 4s plus 4. But what we have here is positive 8, positive 8, and you only have positive 4. So which is not enough. We need to add 4. Okay, so we need to add 4 here. So this means that this one also add 4. So now the answer will be 2s minus 2 square plus 4. Okay, you already know the answer is this one. And then we change inverse Laplace transform of 2s. I copy down again from the question. We change a new answer. So this one, what we obtain here is 1 over 2 inverse Laplace transform of the 2s minus 3 divided by s minus 2 square plus 4. Okay. Now, if we want to apply first shift theorem, as I mentioned to you earlier, this is the example for the first shift theorems. We need to know the first shift theorems. The first shift theorems is let's say s minus 2 over s minus 2 square plus 4. Let's say you have this one. You will obtain exponent 2t, and then you have inverse Laplace s over s squared plus 4. So this s plus 2 numerator, in order to apply the first shift theorems, the numerator must be s minus 2 and denominator also have the s minus 2 in order to apply the first shift theorems. That what is the remaining is, okay, if you apply the first shift theorems, you will obtain the exponent 2t, which is the 2t is from the 2 here. And then the remaining is the s. And then this one you already apply the first shift, so remain the s plus 4. This is the same. Okay. Okay. After you know this, we go to next one. So it's equivalent to half of the inverse Laplace transform. We apply the first shift theorem, means that we need the 2s minus 2 plus 1. Okay, why plus 1 here? Why I said plus 1 here? Because if you look at here is 2s minus 4 plus 1. Okay, let's not talk about the plus 1 first. 2s minus 4. But what we have is only minus 3. And yet you have minus 4. So we need to plus 1 so that your answer will be 2s minus 3. Okay, so this is the purpose of plus 1. And then others is remain the same. So s minus 2 square plus 4. Now we apply the first shift. So this one, we take it out. So we have the 2 inverse Laplace transform s minus 2 and s minus 2. So you have a s minus 2 over s minus 2 square plus 4. And then plus with inverse Laplace transform 1 over s minus 2 square plus 4. Okay, so we still have 1 over 2. 2. Okay, just now I mentioned to you here, this one is the shifting, first shift theory. So you have exponent 2t. And then inverse Laplace transform, you have the s over s square plus 2 square. Plus, okay, this part, we have the exponent 2t inverse. And then we have s square plus 2 square. Okay, we can cancel out the 2 here. So you have exponent 2t. This is the format of the cos. So cos 2t. And then plus with half of the cos, half of the exponent 2t. This one, okay, we need to change to a sine form. Okay, sine at is equal to a over s squared plus a squared. So we need to divide by 2. So okay, if I write like this, I will have 2 over s squared plus 2 squared. But I need to divide by 1 over 2. So I divide by 2 to cancel out the 2 and 2 here. So at the end, my answer will be exponent 2t cos 2t plus 1 over 4 exponent 2t sine 2t. Okay, that's all, and thank you for watching. Hopefully you can understand how to solve the inverse Laplace transform using the first shift theorems. Thank you.